In example 1, we need to convert the polar coordinate 6, 120 degrees to a rectangular coordinate. To do this, we're going to utilize these formulas. X is equal to r cosine theta, and y is equal to r sine theta. If we use our values r and theta, we'll find x to be 6 times the cosine of 120 degrees, and then y will be 6 times the sine of 120 degrees. 6 times the cosine of 120. Cosine of 120 is negative 1/2. Sine of 120 is root 3 over 2. The x part will simplify to negative 3, and the y part will simplify to 3 root 3. So to write your coordinate, you're going to write negative 3 and then 3 root 3. That's your final answer for example 1. We've taken r and theta and changed it to a rectangular coordinate. It's often a really good idea after you get done with this to think about where that is. So if we use r and theta, 120 degrees would be here, and let's make this arbitrarily 6 units long. So that's in quadrant 2, and then negative 3, 3 root 3 would also get us to the same location in quadrant 2. Let's do another example. Let's do example 2. Just give me a second here to get that out. And example 2 says convert negative 4, 145 degrees. And actually, if you want to make a note of this, this should be 135 degrees. We could do 145, but this is not going to work out as well as 135 would. So we can use our same formulas. X is equal to r cosine of theta, and then y is equal to r times the sine of theta. So in this case, 135 degrees is going to be negative root 2 over 2, and then negative 4 times root 2 over 2, and this will be positive. This angle, 135, and this point would actually be over here. We've got a negative radius, so instead of going in the 135 direction, we're actually going to go this direction. So we should find a positive x value and a negative y value. Let's see if that happens. So negative times a negative is a positive. 4 over 2 is just 2, and then we've got a root 2 there. This one will be negative, and then 4 over 2 is 2, and you've got root 2. So the coordinate pair is 2 root 2, negative 2 root 2. And that does work. We would notice also here that if this were drawn perfectly, this x and y would be exactly the same value, with the exception that the y would be definitely negative. And that's what we have here. And we can do maybe one more, so we'll do example 3. And in example 3, we're asked to change 4 pi over 6 to a rectangular coordinate. We know that's in polar right now because we have a radius and we have an angle measurement. So x will be 4 cosine of pi over 6, and y will be 4 sine of pi over 6. The cosine of pi over 6 is equal to root 3 over 2, and the sine of pi over 6 is 1/2. This angle, pi over 6, is right here, and then 4 units out might be something like this. So x will be 2 root 3, and y will be 2. We need to write our ordered pair in the rectangular coordinate system as 2 root 3, 2. This makes sense in terms of this drawing as well. Both x and y are positive, and you can see here that we're in quadrant 1. And we might be able to knock out one more here, so we'll get to example 4. And so for example 4, we're going to do the same thing. We're going to convert this to a rectangular coordinate. So x is equal to r times the cosine of 13 pi over 3. And then y will be 0 times the sine of 13 pi over 3. Now something interesting is happening. If we take a look at what this graph would look like, wherever 13 pi over 3 is, we don't go out any amount, so we're right here at the pole. We know this is going to have a coordinate of 0, 0. If we change it into rectangular, doesn't matter what the cosine of 13 pi over 3 is, 0 times that number is 0, and 0 times whatever the sine of 13 pi over 3 is also 0. So yes, this is at the pole, but this one is the origin in terms of the x and y coordinate system. Anytime you have a radius of 0, doesn't matter what angle measure you haven't gone anywhere, so you're just right here at the origin.